In modern warfare, speed can decide the outcome of an entire conflict. For decades, ballistic missiles have been among the fastest weapons ever created. But a new generation of weapons is pushing those limits even further. Weapons that can travel 5 times faster than the speed of sound. Weapons that can maneuver while flying. Weapons designed to evade modern missile defense systems. These weapons are known as hypersonic missiles, and one of the countries developing this technology is Iran. In recent years, Iran announced a new hypersonic missile called Fatah. But what exactly makes a missile hypersonic? And how advanced is Iran's technology compared to other global powers? Before we dive into the technology, if you enjoy deep documentaries about military technology, missiles, drones, and future weapons, make sure to subscribe, press like to support the channel, and help the video reach more viewers. And share this video with anyone interested in modern defense technology. Now, let's explore the science behind hypersonic weapons. The speed of sound is known as Mach 1. Aircraft that travel faster than sound are called supersonic. But hypersonic speeds go far beyond that. Hypersonic vehicles travel at Mach 5 or higher. That means more than 6,000 kilometers per hour. At these speeds, air behaves very differently. Extreme heat forms around the vehicle due to air friction. Temperatures can reach over 2,000 degrees Celsius. Designing vehicles capable of surviving these conditions requires advanced materials and engineering. Hypersonic weapons typically fall into 2 categories: hypersonic glide vehicles and hypersonic cruise missiles. The system announced by Iran appears to be a maneuverable hypersonic ballistic missile. Iran has spent decades developing its missile technology. Because of international sanctions restrictions, the country invested heavily in domestic defense engineering. One important missile in this development was the Shahab-3. This missile gave Iran the ability to strike targets at long distances. Over time, Iranian engineers developed newer missile families with improved range, accuracy, and propulsion systems. Eventually, this research led to the development of the Fatah hypersonic missile. Iranian officials claimed the missile can travel at speeds between Mach 13 and Mach 15. If accurate, this would make it one of the fastest missile systems in the region. The Fatah was unveiled in 2023. According to official information, the missile includes several advanced technological features. First, it uses solid fuel propulsion. Solid fuel allows missiles to launch quickly without lengthy preparation. Second, the missile reportedly includes a maneuverable warhead. Traditional ballistic missiles follow predictable paths, but maneuverable warheads can change direction during flight. This makes them much harder for defense systems to intercept. Third, the missile is designed to travel at extremely high speeds. These speeds reduce the time defenders have to detect and respond to the attack. Missiles require powerful propulsion systems to reach hypersonic speeds. Most ballistic missiles rely on rocket engines. These engines burn fuel and oxidizer to produce high-velocity exhaust gases. The thrust generated pushes the missile forward. In the case of the Fatah missile, engineers reportedly used solid fuel rocket motors. Solid fuel offers several advantages: simpler storage, faster launch readiness, reduced mechanical complexity. However, achieving hypersonic speeds also requires advanced aerodynamic design. Missile bodies must be shaped to reduce drag and survive intense heating. Materials must also withstand extreme temperatures created by atmospheric friction. One of the key features of hypersonic weapons is maneuverability. Traditional ballistic missiles follow a predictable arc through space. Missile defense systems can calculate this trajectory and intercept the missile. Hypersonic weapons attempt to defeat this strategy by changing direction during flight. They become harder to track. Iran claims the Fatah missile includes movable control surfaces and thrust vectoring technology. These systems allow the missile to alter its flight path, if accurate. This could complicate interception attempts. Many countries have developed missile defense systems. For example, Israel uses systems like Arrow 3. These systems detect incoming ballistic missiles using radar and launch interceptors to destroy them. Hypersonic missiles create new challenges for such defenses. Their high speed reduces reaction time. Their maneuverability makes trajectory prediction more difficult, and their flight path may occur partly within the atmosphere. Because of these factors, defending against hypersonic weapons requires new technologies. Iran is not the only country developing hypersonic technology. Major powers are investing heavily in similar weapons. The United States, China, and Russia are all working on hypersonic systems. For example, Russia developed the Kh-47M to Kinzhal. China has tested the DF-17. This global competition has created what many analysts call a hypersonic arms race. Countries are racing to develop both offensive hypersonic weapons and defensive countermeasures. Hypersonic weapons represent one of the most advanced technologies in modern military engineering. They combine rocket propulsion, advanced materials, precision guidance systems, and extreme speed aerodynamics. As technology improves, these systems may become faster, more accurate, and more maneuverable. At the same time, new defense technologies will emerge to counter them. The future of warfare may depend on who can master this new frontier of speed. A battlefield where weapons move so fast that the difference between detection and impact may be only seconds, and where the race for technological superiority never stops.